Okay, fifth graders, let's go over the problems that you had in your math lesson today for a warm-up. 375 times 9. I estimated first, got 400 times 10, equaled up to 4,000. When I got 3,375 for my final product, I felt okay about that because it was fairly close to my estimation. If I had gotten 375, then I would have had to gone back and try to find out where I went wrong, because that would have been not anywhere near my estimation, right? So here's the other one that we did. Let's do this one together. 1,342 times 6. I rounded that, or estimated it, used rounding to estimate. 1,000 times 6 got 6,000. Now let's do it for real using our standard algorithm. 6 times 2 is 12. That's one group of 10 and 2 ones. And some people like to circle the number that you're regrouping just so it stands out. And you can do that if you want to. 6 times 4 tens. That's 24 tens. Plus one more 10 is 25 tens. Well, there's my 5 tens. My 20 tens is the same as 200. So I'm going to put it in the hundreds column. Go ahead. Next one is 6 times 300. It's going to be 1,800. Plus these other 200s that are up there, 1,900, 2,000. 2,000 is the same as 2,000, so I'll put it in the thousands column. And that left me with no extra hundreds. And then 6 times 1,000 is 6,000, plus 2 more 1,000, 8,000. And that's my final answer. Even though they're not exact, they're close enough so I can feel comfortable knowing that I'm in the right ballpark. All right, let's go to something that might be a bit new for you. It's when we have a 2-number multiplier, or one of the factors is 2 digits. And let's go ahead and see how we attack this one. Well, first of all, if this was 45 times 3, I feel pretty confident we could just knock that out, right? So let's go ahead and do that. 3 times 5 is 15. That's one group of 10 and 5 ones. Let's have our place value places. And then 3 times 4 tens is 12 tens, plus one more is 13 tens. 13 tens is the same as 100, and 3 more tens, 135. So we have completed the problem as if it were just 45 times 3. We don't just have 45 3 times, we have it 23 times. So we're going to have to multiply this amount, 45, 20 more times. So when we're going to be multiplying 20 times 5, right? 20 groups of 5, and then 20 groups of 40, right? This is not a 2, it's a 20, right? What do we know about if we multiplied 2 times 5, it would be 10. But if it was 20 times 5, we know since this number is 10 times greater, the final product is going to be 10 times greater as well, right? So I'm multiplying 20 times 5, not just 2. So what I'm going to do is I'm going to get ready for my second row here. And I'm going to put a 0 there to indicate that all the answers I get for this one, there you go. I put a 0 right there because I'm now going to be multiplying 20 times each of these numbers. I've already done 3, and now I need 20. So although I can say 2, I really mean 20, right? So I put that 0 there to indicate that all my answers, all my partial products I get are going to be 10 times greater than if it was just a regular 2. So 2 times 5, and I'm going to also cross out the regrouping I'd done for this first number. I'm now on 20 times 5, 20 times 40. So 20 times 5, well, 2 times 5 is 10. And since I'm using the standard algorithm, I can say 2 times 5 and get 10, even though I know that the answer is actually 10 times greater than that. And then 2 times 4 is 8, plus one more is 9. And I'm finished with that. I add together my 2 partial products, 5, 3, and 1,000. So I ended up with 1,035, which is very close to my estimation. So I'm feeling pretty good about that. Just what you need to remember is this, remember what place value place your numbers in, right? If this is 20, it's going to be 10 times greater. If I say 2 times 5, 2 times 4, it's really 20 times 5, 20 times 4. It's really 10 times greater. So in the standard algorithm, I can solve that issue by putting a 0 there to indicate that all of my answers are 10 times greater than what I'm saying, because I'm going to say 2 times 5, 2 times 4. But the answer is 10 times greater. So keep that in mind as we're doing some double-digit multiplication problems.